Well, should we go back to open discussion then? Let's go back to open. We'll go back to open discussion. I will throw the doors open for the evening.
Hey, I got this article I wanted to share, if that's okay.
Yeah. So I guess the only thing that I should probably mention is, and I would caution everybody about when you're playing videos, every now and then we run into issues with copyright stuff, videos with sound especially. So just be aware.
Yeah, this isn't a video.
Yeah, no, I'm just saying in general. Last week, Jeremy Reese was playing BBC. He was using some examples from the BBC, which is okay because it's on YouTube. He's just playing YouTube, but then Google blocked it as a re-upload. So
what I have here is an article in physics, and it's titled "Using Time Dilation to Measure Curvature of Space-Time." A team of researchers working at Stanford University has used time dilation in an atomic fountain to measure the curvature of space-time. In their study reported in the Journal of Science, the group used the fountain as an interferometer to measure atomic wave packet changes that corresponded to phase shift. The atomic fountain created by the team consisted of a 10-meter tall tower containing a vacuum tube. On top of there was a ring securing a piece of tungsten. To use the fountain, they fired lasers beneath single atoms, pushing them upward, and other lasers fired down from the top to stop them. A third laser pulse captured the atom as it reached the bottom. In their experiment, the researchers pushed the pairs of atoms up the fountain and measured resulting phase shifts as they traveled up and down the fountain. Phase shifts were initiated by stopping the atoms at different distances from the tungsten at the top of the fountain. The setup demonstrated phase shifts due to time dilation, in which is described in Einstein's theory of relativity, time passes more slowly closer to massive objects. In the fountain, the atoms that rose higher moved closer to the tungsten mass and therefore experienced more acceleration, which led to a time shift between those and the atoms that did not rise as high. The experiment also showed that the Aronoff bomb effect also applies to gravity, as a magnetic field inside of a cylindrical container can impact particles that never make their way inside the container. In their atomic fountain, electrons take unique paths up and down the fountain, which were forced into superposition. And despite the magnetic field in the chamber, no magnetic force was exerted on them, but there's still evidence of a magnetic field shifts. So I thought that was interesting because it shows that gravity actually slows time the closer you get to the massive object. And that was my share. Thanks.
Jeremy, how are you handling the snowstorm? You're right there in the epicenter of it.
It is a nightmare here right now. It is. I was out shoveling for 5 hours and I barely got like a mile down the road. And my van just does not do good in the snow. It just kept getting stuck.
Yeah, that's why you started the stream a little late today. Got stuck out there.
Wow, I was not even aware. It's 64 degrees here and it's going to be warm the next 4 days before we get another dip down to the sub-zero range.
So one other thing too is I wanted to mention for you guys, there's this that material that Hal Puthoff was showing off the Linda Moulton Howe material that was like the terahertz waveguide that was bismuth and magnesium. I contacted a couple metallurgy contractors that make like specialized metals, including like specialized in metal thin films and stuff. And I'm going to see if we can try to get a sample made to those exact dimensions, like the 3 microns bismuth to 150 microns magnesium or whatever it is. So we're trying to, I'll see what they have to say about that, because there's a lot of claims going around out there that that material would be hard or impossible for, you know, humans to make or whatever. So yeah, we're gonna try and see if we can hire a company to build some of that stuff for us, and then
How thick
you know.
was it, did you say?
Jeremy, if you can make it fit inside this square, we can stick it inside the inside the experiment and see what happens with dynamic nuclear orientation.
Yeah, that would be cool. I'd like to actually. Does a ping pong ball fit through that square? Because I'd like to see if we can get like a thin film, like cold, like if they do cold spray or some of these other depositing, you know, techniques. I'd like to see if they could do it on the surface of like a ping pong ball, so we can make like a sphere that was, you know, like coated with this
Probably
material.
smaller than a ping pong ball. Like
You
there's,
could
I don't know if the width.
A ping pong ball is a good standard size though, and Keshi is also used those in theirs. So I would suggest going
Oh, to run it in that experiment, it would need to fit in
with
here. I don't think
that.
ping pong
Jeremy has
balls
a good
fit.
size reference.
How big is it? How big was their sample, Jeremy?
I have no idea how big the actual their sample is, but we're just gonna try to. I mean, there's specifics in a video I have. Let me see if I can find the video.
Was it thin? Was it real thin, or was it pretty thick?
Hey guys, can I ask a question? It's just a bit of a strange one, given the news. I just dropped a picture in the chat window. Does anyone believe in exopolitics? Exopolitics, i.e. those up there watching down on us. Do you think they'll intervene this time? Put us in the place of our technology? We should be concerned, really. So it's like 1962 again, isn't it? Yeah. We're talking about the standoff. I'm just throwing in a wild card. We're talking about the standoff between the West and the East, the West and Russia. Russia apparently are going to up the ante, and they're going to put missiles in Cuba or Venezuela. So it's just it's building up, isn't it? Because it might be it. It might be it. But apparently those upstairs, they have the technology to convert it all to iron 56, convert the plutonium to, they apparently did that at Rendlesham Forest, which is about 100 plus miles away from where I am. And just as a demonstration, in a few other places around the world, they would fly over bases and make the technology go haywire. Do you think they'll save us? That's just a question I'm asking.
Yeah, you posted a picture of something,
Yeah.
right?
It's
Yeah.
a news article that they plan on moving military hardware into Cuba and Venezuela.
Yeah.
I asked that we not talk about politics here unless it relates to UFOs. So Remy, flying to this technology, to alternative propulsion.
Oh yeah,
Yeah.
because politics is yeah, especially when we started, right? The golden days of the Trump administration. Yeah, so politics is a hot button
Okay.
issue.
I'm thinking more about the
Politics has
technology. I
been a
mean, do you
hot
think they'll
button
save
always,
us? Do
so.
you think they'll save us this time from ourselves?
I don't think so. I think
I
that,
say we
Save
wait and see.
ourselves,
You can't
and
do
it-
anything about it. Just, keep working on what you're working on, because,
Yeah,
if we
Exactly.
keep busting hump to get to where we're trying to go to, we may be able to save ourselves,
fear is the enemy. Fear is
Hey,
Law
that
of
might be the
attraction.
solution too. Instead of developing warp drive, they may not be willing to contact us until we literally find a way to stop
Indeed.
That's the prime directive.
save
That's,
ourselves and,
they're waiting for that
End up
awkward
fighting.
moment.
yeah.
wait until we're no longer fighting with each other,
We have to stop killing ourselves before we're allowed off. And it's all about the law of attraction. And the more you focus on the
I think Bernie just cut off, but
negative,
yeah,
the more
the
the
law of
negative
attraction
comes.
is, the law of attraction is very real. And the more you think of negativity or bad stuff, the more you're gonna attract it to yourself.
That's
I
true.
think you should probably
That's
look
true.
deeper into the parasites that they think are linked to schizophrenia, which, comes with hearing voices that you can't stop for some reason. It's like, that's kind of what a nanobot that connects you to other people who have nanobots so you can hear their thoughts would do,
Yeah, it's karmic delusions.
Well, as I say, Toxoplasma gondii, when you look at the archaeological history on it, dead ends where there was basically a meteor that hit South America, and there's a parasite that has a dead end somewhere near a meteorite impact in Africa that is the only other organism on the planet that shares similar DNA.
Hmm.
They don't seem to be connected to any other pathway in genetically to anything else on the planet. And that the parasite in South America, when it hit, that's when everybody went from doing brain surgery and building those magnificent structures and whatnot to, killing each other and sacrificing children and drinking blood. And that would, if you suddenly introduce the capability of something like that without letting somebody know what it is, that would terrify somebody. I mean, if you knew it was another person thinking, then it wouldn't be anywhere near as terrifying as worrying that it might be a demon trying to talk to you,
yeah.
So,
Well, now we're getting into religion.
Yeah, yeah, I know. We're
well, this is based on biology, though. I mean, we know these parasites exist. We know they have the ability to manipulate behavioral patterns, because rats who are infected with it will suddenly no longer have a fear of cats, and they're
Yeah.
attracted to their urine, so they'll hang out places where cats are basically living and get eaten. And the biology of the parasite cannot replicate indefinitely when it's in anything other than a feline. Once it reintroduces into a feline, its life cycle is reset so that basically the whole colony won't just die. Every generation is just a baby,
Yeah.
Whereas in a rat, they
Sounds a
their
bit like
telomeres start
Stargate.
breaking off. It
Sounds a bit like
does. It
Stargate
does
and
a
the
little bit.
gold.
Hold
the
on,
gold,
Imagine
the
if it's not.
parasites.
Imagine if it's
Mark,
not actually sentient. It's just
let
a
me ask.
mechanism.
Let me ask Mark. Is it okay if I make you the host?
Sure, you gotta run.
Yeah, I'm gonna I gotta make dinner for the dogs and all that stuff. So okay.
Ooh, your dogs are,
Yeah, well, it's that time of the night, right?
Having steak.
Okay, so let me do that then.
my dogs only get dog food. I get them the premium stuff, but Jeremy's kids came down this last weekend and they were feeding him her crap, and that's what came out.
Yeah, my cat has diabetes, and it got it from the cat food, because the cat food it's all full of carbohydrates.
Yeah.
Non-meat stuff. So now I have to give my cat 2 insulin shots. I got to give it a shot twice a day. And what I feed it is I buy mackerel, canned mackerel. And then, so it's like pure meat. And then there's a food supplement called Al Nutri or something like that, that I add a teaspoon of this in the can of cat food. And it's lowered the cat's blood sugar, and it's also better for the cat.
And the same, Michael, the same is true for dogs. I think, I mean, I don't know if they lie. I know they don't have the same quality standards. Another thing I know is the meat that they put in dog food. If you ever read the preparation procedures, basically they take it up to a high enough temperature for a long enough period of time that the protein breaks down. It's no longer identifiable as an animal, to be honest. And I've read that before. And so So what I do with my dogs is I boil chicken every day. But I had the same problem. I've had 2 rescue dogs in the past that were on dog food, and they both ended up with diabetes because it's so loaded with carbs.
Yeah.
And
It's
so,
cornmeal. It's like 99% cornmeal, and then
Terrible.
just a little bit of like grease flavoring to make it
You
taste like meat
poison
or
your
fish.
pet when you
yeah,
feed-
And with a dog, it's a little easier to do that with because dogs are not, they're not even omnivores like us. We used to be scavengers, which is a next step beyond being an omnivore that can not only eat anything, plant or animal, but it can eat rotten plant and animal without being harmed by it, right? But with a cat, it's all smooth intestines. It's only built for eating meat. It's not made for eating all these plant matter that basically end up rotting in their intestines, and they can't, it just ends up binding them up.
Bad. It's really bad. My
Yeah.
cat.
Right, and like I said, think about the vegetable problem. Well, now imagine a grain problem that requires even more. I mean, cows eat grain. They also have multiple stomachs.
yeah, and
That's
I
true.
think a lot of it with dogs, I think a lot of it comes down to, I think that the manufacturers are disingenuous about how much carbs, because when you read it, it's
Yeah.
like meat, but
They should have a warning label that they put
Right.
that
They don't need the nutrition label because it's not for
Yeah.
humans, and the FDA hasn't gotten involved.
not fit for human consumption, you know.
well, and they say that on dog
Right.
food.
So
They say that, yeah.
It's really criminal what they're doing if you think about it, because they're killing our pets and we're like slowly poisoning our pets and we're thinking we're helping them. The other thing that I think is interesting about this pet food thing is there are a lot of places there are shortages of pet food because a lot of it's shipped from China. And so like in California, there's a lot of
That's an issue because they found a lot of the Chinese food that was coming in, both formula and for animals, had a lot of plastic that on testing looks like protein, but it's not. It's a polymer chain from plastic.
Guys,
Yeah.
can we get back to the
Yeah.
research?
Yeah, let me go and do the
We're here
dog
talking
thing.
about dog food.
Okay. Yeah, the editing on this one will be
My dog is
interesting.
a demon. Swear to God, my dog is a demon.
Lulu, you missed the
Okay.
boat. We're not talking about dog food anymore.
Hey
Talking
man,
about
sometimes you have
animals
to
and pets. I've been
decompress to have a
having
good
trouble with my
conversation.
pet. Like,
That's
Lulu,
yes.
Lulu, I'm
listen.
still counting on you for those shelves for the drawers.
Okay.
Listen, I'm still gonna do it. I'm looking through. I have the Uline catalogs. I want to flip to see if there's something close, and then I could refer to them to and just to. I still have to do a lot of cross comparison, but I haven't forgotten it. I promise.
Okay.
No, I'm telling you, it's one of the coolest things. You're like creating a system that's real. It's not just hypothetical in La La Land, like real. Yeah. So, good job.
Thank you. Yeah. The idea was great. It's the implementation. Lulu was when she was here at the lab was planning on putting in a shelf system to allow us to access the boxes that are behind the other boxes. But it's a little bit more complicated to implement than just the idea alone.
I mean, the more I know, the more I understand science, I go, what kind of products do I want to use for this stuff? Like at the end of the day, we're it's a magnetic field, and these things, I was there, these things flip, like stuff just moves. I'm like, cool. I'm telling you. So you have to know, like, what do you want to use as the container? I don't know. Maybe I'm thinking too much of it, but I mean, we're talking about quantum stuff. So on a quantum level, that it still matters, like this is all.
Moz said online. Moz said on the YouTube link that we need a Lulu in every team.
Thank you. Listen, I had so much fun. I learned so much. I heard of this stuff, but I never saw in action. Like, okay, how do you get a team? Like, how do you have energy flow through a team? And everybody on the dot. It has to be a homogeneous team in order for the energy to flow. I was constantly like trying to, any interference, anything like that drops on the floor or anything that's out of place, it's not aligned right, it's gonna somehow like interfere with the energy flow, of the space. And we're playing with magnets, we're playing with high current, current, voltage. So that stuff affects us, as humans. And, we're all, if you want to call it, engines. And to be productive and to work together and all of this stuff, there has to be a frequency. But if we have a lot of peripherals and a lot of little things where the energy is just bouncing negatively, then, one of us will like flake out. So, I was trying to get that flow. You guys did not realize I was doing that, but that's just, the things when I picked them up, those were causing like an interference in the frequency of propagation, energy flow, for us all to be connected all at once from different ports, different, cameras, different computers, even our physical effort. We give energy to each other. We like, when everybody's excited about something, we constantly like, it's like ping pong, if you want to call it, back and forth, and that's a good thing. And that's how you build things, that's how you grow things, that's how you make a team, that's how, when everybody understands each other just at a whim, like, not, you don't have to give specification. And I didn't know a lot of these things, but I learned, and the more I'm here, I learned like more, and I'm like, my gosh, the possibilities, like, my gosh. Yeah.
So we got some new people here in the chat, on the Zoom call. Abraham, are you new? Oh, we can't hear you. There was some other new people as well that signed off already.
I'll say, where's Jeremiah?
Jeremiah's been AWOL for the past since the new year, pretty much. You haven't heard from him. Has anyone heard from Jeremiah?
I hope he's okay.
Yeah.
Join the technicians.
Smart people, like everyone's smart. What do you think is the common denominator between all of us? I mean, I was thinking in terms of mathematics and things like that. If we have to have some common denominator, is it just the hashtag of interest, or is it really more fundamental than that?
I found an interesting common denominator between people who are interested in alternative propulsion is that they're also interested in psychedelics and exploring the psychospace.
Consciousness.
Yeah. The study of consciousness and the study of alternative propulsion have this weird, parallel.
I mean, I have a lot of theories, but I don't know how to prove it exactly because I don't have like the machines to do it. But according to the fundamentals, if space holds memory, then wouldn't, like, when Earth rotates, like somehow when somebody thinks of something, when the next person in that order of rotation will think of it too, because if it's something that sparks a higher
I don't know
energy,
if it works like that, but there is a phenomenon in science where somebody on one side of the world is discovering something independently from somebody on the other side of the world, and they happen simultaneously.
light bending. Light bending.
The synchronicity that happens is more than just coincidence. We found that with many discoveries, and the co-discoverers didn't know of each other at the time. It's not like they were working together.
Did they have anything that was a common denominator other than, like, at the same time they thought of the same thing?
Critical mass consciousness and like the 12th monkey sort of, I think is.
I was thinking, let's say, more of the nucleic acid on a DNA level, or I was thinking of the synchronicity of, let's call, time, like birthdays. Or major events that happened, like that caused a lot of energy outbursts, from the planet, or made a huge impact on the evolution of humans, like, scientists, like, the Einstein, Tesla, and we can go back further, like,
something
the
you might
Atlanteans,
try.
so on. Yeah.
Something you might try is to look at it from a completely alien aspect of how would you go about developing the technology that we have that we find absolutely necessary if you lived in a completely different environment that you evolved from, like on an aquatic world. They wouldn't be able to just develop fire. So there'd have to be a different chain and path for them to do all the things that they do. And by looking at the differences, I think you'd begin seeing more of the similarities between humans and why we are arriving to the same conclusions so often, even when we're so completely disconnected. Because as a world, we're advancing at about the same speed. So we're working with the same building blocks. And therefore, when you have, billions of people, obviously 2 people doing the same thing is not really going to be that big of a stretch. Right. So
Wouldn't there be a middle line though?
well, here's a way to look at it. How would we have developed if we had 6 fingers? Meaning that when you count your 2 hands together, you get 12, not 10. So therefore, all of your math would be based either on 6 or 12, instead of us being defaulting to decimal.
Well, that our
Maybe
time
so
is based on 12.
numerically we do account for 2 invisible ones because everything works, all mathematics works on time works on the idea of 12,
Well, that may be why pi doesn't
so,
divide properly into an even number. Or if we were using a different numeric scale, we may be able to get a definitive number that's only like, say, 3 decimals.
Okay,
To,
how do we
measure
divide
the
time?
circumference.
We divide it by 24, and we have different 24 time zones. But is it really 24? Are we maybe maybe it's less, but we're adding those 2 just because those 2 with the curvature, we have to, to account for space.
Well, and here's a question.
Kind of stuff.
When we're drifting away from the sun, so that means that our path around the sun is getting further. So are we slowing down the rate that we're rotating or accelerating the rate that we're going around the sun in order to make sure that that numeric value has remained the same too? And how would that change if something were altered on that so that our rotation were different? I mean, look at Venus. Venus spins backwards.
We evolve.
Right, but Venus spins backwards. So what would that change?
It doesn't matter. We're the conscious being. We create a ripple effect, and everybody aligns to that new, energy field.
Right, and what I'm saying is, how would that affect their progression as a species living in a different event like that? And therefore, how does that affect us being what we're in?
Or are they like the invisible species, and they're only detectable through infrareds and like the things that the human eye cannot perceive? Or we're talking about like things that are detectable with machines, not human eyes. If that's so, then we send signals of agreement or not. If we get
hold on, you're
back
something else out though too.
then we know it's not
right.
so.
What if they see in a different spectrum too? How would that,
be
like
so
bees?
cool.
Bees are able to see
My
ultraviolet
gosh,
spectrum we can't see. How does that affect their evolution if they decided to be, if they were given time to evolve to where they could start developing technology? What would they
Aren't
do
they
differently
already
than
evolved
us?
more than us? Well, you're just saying that,
A bee?
how would that, but they're already evolved more than us. What if that actually is like the starting point where, everybody evolved at, with the wave. And that's just part of
one
the
second,
cycle. And
Lulu.
they're gonna probably acquire a new, ability with the motion that we start from here. I mean, think about it. I mean, it makes sense. We're the green planet or the pale blue dot, but no, really, we're like, the planet that has life and visible life, reflective life. Our ozone layer reflects.
Stephen actually has been raising his hand for a while. I just want to give him a chance to say something. And by the way, we're in open discussion right now, so everyone can chime in. We just ask that you turn on your camera if you're talking, so everyone can see who we're talking to. Hey, Stephen.
Hi, I'm Stephen. Bob invited me here. I'm a donor and guess a thinker, but not really a experimenter. But one of the things I was interested to find out from you is who is a maker in the key areas, like using the needle-shaped cathode, emitting ring-shaped energy evos, who's doing sonocavitation and collecting energy that way, who's spinning magnets and collecting energy that way. And apart from those 3, what have I missed? And
Well,
what do you
Mark,
need? If you're in those areas, tell me what you need to advance.
We all
Well,
are.
There's no, we're not all. There's a couple people working on sonic cavitation. Todd Asiato that was on earlier is actually working on some ultrasound experiments. We have a high-speed camera to try to get standing waves in space. Over here at the Falcon Space Labs, we're working on quite a few experiments with dynamic nuclear orientation. Basically, we're trying to get the subatomic particles in the core of the atom to spin in alignment, and that theoretically should provide some sort of gravity shielding or inertial mass shielding effect, which could explain how flying saucers operate. We're also working on gyroscopic propulsion systems. Spinning magnets is something we've done quite a few times. Todd Asiato has also tried that. Jeremiah Pop has also tried that. Seen some interesting results. Nothing more than 5% thrust to weight ratio so far. But really the main roadblock over here is getting competent engineers into the lab. They're kind of hard to come by, and as you can see, this is a very diverse group over here. A lot more theoreticians than there are engineers. And generally, for every 100 theories, there's one engineer that's actually trying something, and that engineer has his own theory. So that's Michael Boyd's laughing his head off because he knows it's true.
Yeah, I'm working on nano gravity, basically using a disk. I have like 4 patents and a 5th one pending on this. What it does is it takes nano bumps and nano pits on the surface of a hard disk drive, and it produces a different kind of magnetism. It's called gravitomagnetism. It's produced by the presence or absence of matter on a spinning object, essentially. And it's something I measure using a thing called a giant magnetoresistor head. It's a little tiny resistor, nano resistor, but it's made with a special material that's sensitive to changing magnetic fields. And then I also measure it with a little force sensor. It's a piezoelectric crystal on the back of the little head slider. And essentially, I've already got patents on that. And then what I'm working on is taking the little nano bumps that are in the center of your hard drive and mapping them out and using them to create private keys for private key, public key pairs for basically for making immutable cryptographical data exchanges, essentially a new type of cryptography. So that's what I'm working on. Thanks for your interest too. It's appreciated.
I have a question for whoever is capable of answering it quickly on top of their head. I did a little test, gravitational shielding today, in which I assume that gravitons, when they're traveling through the Earth, they're gonna lose energy because they're gonna transmit their energy. They're gonna lose energy because the atoms of the Earth are gonna gain energy, so there needs to be a balance there. Gain kinetic energy by moving in the opposite direction. So I kind of assume that the gravity of the sun would attenuate during the night as compared to during the morning. And I did the measurement of the.
Say that again about the thing, the difference. What the gravity's different in the night and the day? Is that what you're saying?
Yeah, the gravitational acceleration is I made the assumption that would be different because you know, the sun is
The lunar
kind of
tide?
aligned.
Is it because of the lunar tide? You know, like water shifts to one side of the Earth versus the
something like
other
that.
side of the Earth, and so that makes it, you know.
I get what you're
Like-
saying. You're physically closer to the sun on one
So there is
I mean,
this,
right?
side than the other, so the gravitation, that makes sense, your question.
so
Yeah,
this effect that they've found with coronal mass ejections, you know, that is a coronal mass. So basically there's two phenomena that occur on the sun. The first is called a solar flare. And a solar flare basically pushes photons out into space at the speed of light. And a solar flare takes approximately 7 minutes to reach the Earth. On the other hand, there's this other phenomenon called a coronal mass ejection. And what that is there's a basically part of the sun's surface is thrown out into space. It's what's called a proton flux. And it actually produces a gravitational wave of protons. It's a 1,000,000-mile wide wave. And it comes towards the Earth. And because it's traveling at the speed of gravitation, it's slower than the speed of light. It actually takes 2 to 3 days to hit the Earth. And when it hits the Earth, it actually causes the magnetic field to go whipping around, and it can actually cause blackouts because the power lines will get like charged up and actually can cause it to overload. So, and that's happened before a lot of times, most recently in Canada. But the really cool thing about this is on the other side of the Earth, when there's certain radioactive materials that when a day or a day and a half before the coronal mass ejection, the radioactive decay rate slows down for these radioactive elements. Okay, and so actually the gravity does affect what it does is this proton flux hitting the Earth. This affects the rate of radioactive decay.
yeah.
And so,
Acceleration.
and they can measure it, and they can measure it over time, and they'll get the time will slow down. But what's cool about it is it happens. It's like projecting into the future that in a day and a half it's going to have this coronal mass ejection. And if you guys are interested in this, if you go back to the April 14th APEC, when I did my presentation, I have a video about that in my presentation that you can check out.
Yeah, interesting. I'll check it out. But your name is Michael Floyd.
Mike Floyd, yeah.
But just to resume what I was saying, anyway, I measured the gravitational acceleration this morning at 8:30. I measured it again tonight at 8:30 p.m. And I was expecting a change, obviously, because the sun would be kind of aligned with the Earth. You would add the gravitational acceleration of the sun and the Earth.
Mhm.
But it's kind of funny because I get this morning I got 3.7. I measured the standard deviation.
Mhm.
I had the standard deviation of 3.7 times 10 to the -6 G.
Mhm.
And at 8:30 tonight, I had the standard deviation of 3.3 times 10 to the -6 G. So I had a weaker gravitational acceleration, even if the sun is aligned with the Earth.
Okay, and where are you located physically?
In Montreal.
In Montreal, so you're at what, 25 degrees?
Yeah.
So yeah, you gotta take into consideration your relationship to the equator,
Oh,
right?
oh yeah, that's right.
And also the planet precesses. Remember that it's not going in a circle like this, it's going up and down. So that could be just basically based on the precession of the Earth, couldn't it?
Okay. So I'm not properly aligned with the sun, I guess.
Well, yeah, you're at an angle.
Yeah.
You know, if you're in the northern hemisphere, where I am in California, I'm at 15 degrees north
Okay.
of the equator.
Yeah. Whereas in Los Angeles or San Diego,
It's 13. 13 is yeah, basically Riverside County is 13 degrees.
okay.
We have a new speaker here, whimsically ambitious. What's your name?
Sorry, yeah, it's Jared.
Hey, Jared.
Hey, how you doing?
Good.
Hey, can I have a little show and tell for a minute here? I've been building the
sure, that's what this is
Graviflyer, and I
about.
think I've got some good principles on how it's working.
Cool.
All right, so far what I've got going on, it's pretty much built, but as I was in the process of finishing the high voltage circuit, turns out I don't have a 47 k ohm power resistor. Shucks, got to wait 2 days now. Anyways, I was gonna say, I think I've got some good ideas on some of his working principles. Jeremy has talked a lot in the past about shape memory alloys, like nitinol. These are things that basically work like springs when they're in one phase, one crystal structure, it's like a cube, and then it gets stretched into its second phase, which is like a rectangle, right? And then when it snaps back through a temperature or a voltage change, it's like a spring, boing.
Torsion.
So, say again?
Torsion.
Torsion, yeah. Well, yeah, I don't know about the torsion stuff. I haven't read up too much on it, but for the Graviflyer, I was testing, because one of y'all were doing the warp drive testing of his Graviflyer, and he put his magnet paper on there. I was like, oh, I should start testing with that. And so I did. The strongest part of the magnetic field is very narrow. It's only like 1/8 of an inch wide, but it's right around the circumference of the magnetic spinning plate, which comes out to a surface area of about 3.5 square inches. So aluminum, it so happens, I found this one good research paper on it, aluminum can display these exact same martensite, rectangular, austenite, square properties when it is subjected to electrical, magnetic, and acoustic oscillations at just the right everything, right? And this is probably why Alexei had so much trouble getting everything tuned just right. It's because he's trying to get all these different forces to be stretching this thing and then letting it snap back and dampening that snap back at just the proper moment to get acceleration, similar to Woodward's Mega Drive that has the piezoelectric stack that is creating like tiny amounts of thrust through nonlinear damping. So that's basically what I got so far. Is I think the Graviflyer is changing the phase of a very narrow region under the strongest magnetic field, strongest electric field. And oh, that was the other really beautiful part I found was the ultrasonic welding techniques that are out there. Basically, you take a piece of metal and you vibrate it about 20 kHz and you can weld it together with another piece of metal. Well, the paper that I was reading about changing aluminum's austenite martensite Bain transformation there was that it has to operate right at about 20 kHz, which, go figure, that's what Alexei's ultrasonic piezoelectric was operating at.
Jared, where are you located?
I'm over in the Northwest.
The Northwest.
Oregon,
okay.
yeah.
Oregon. Can you drop your cell phone number in the private chat? Send me a private message. We have a private WhatsApp group for people who are actually building Graviflyers.
Oh, sweet.
Yeah, and it's sort of like a show and tell, daily, nightly, whenever you're working on stuff. We actually have a CNC machine over here, and I'm about to cut out some discs for people, get them perfectly balanced. So yeah, if you need anything, any help from us, we'll be glad to help out. There's quite a few. There's actually a kid who's working on a PhD using the Graviflyer as.
Oh, Charlie or Charles?
Yes, Charlie Crawford.
Yeah, I've been talking. Yeah, the third. I've talked to him a few times about different questions that I had about it, but he's really busy, so I try not to bother him as much as possible. Although it's almost daily that I want to.
He has to take care of Charles Crawford IV too.
Yeah.
Stephen, getting back to spinning magnets, one thing I noticed about them, and Jared, you might notice this as well, is that for some reason they become very attracted to magnetic north. It's like you have it off, It's as attracted as a regular compass would be. But as soon as you start spinning those magnets, the attractive force to magnetic north goes up. I don't know if it's tenfold or it goes up quite a bit. That's something interesting that I've noticed.
So it amplifies its sensitivity to the North Pole, is what you're saying?
Yeah. If you watch the videos that I posted on YouTube, you got to watch them carefully. You'll notice it swings there. When it's off, it's still. It's not facing north, even though the magnetic field strength didn't change. But when you turn it on, it lines up with magnetic north very quickly, and then it'll overswing a little bit and back and forth. But now I've seen this on several experiments.
How much is it? Does it oscillate around true north? Or I mean, does it oscillate around magnetic north? Or does it sit? It'll reach up.
It sits there as if it's just like a compass needle is attracted to magnetic north. It becomes a lot more attracted to magnetic north, more than you'd expect from a half a Gauss of ambient field strength. I once, in one experiment that happened after the SETI talk, it was live on Jeremy Reese's channel. It's like 2.5 hours in. We did an experiment with magnets that were pointing toward the North Star in line with Earth's spin, and it gained a couple grams of weight when it was spinning.
Did you do that in the Faraday cage?
Inside a Faraday cage, yes.
Okay. Huh, that's interesting. Very interesting.
And some of the experiments were done out of the Faraday cage, like the one where I call it the blue boob experiment because it sort of looked like a blue boob. It was covered so that we didn't get any airflow flowing, perturbing the test, but definitely saw an effect where it was moving toward magnetic north. And I have magnetic north lined up in all the rooms, so we know where everything is, where we're oriented. Roughly that direction right now.
I have a question. They were talking about moon water, like, that if you put water in a bottle and expose it to sun rays, it creates bits of magnets in them. Isn't that like moon water? I mean, like, look, my kids, like, really, they do this for fun, like moon water. They collect rainwater and then they put it in this and they call it moon water because they think the moon's rays. But you guys were talking about the sun's rays. So if I take a bit of this stuff and I put it under a microscope, I'm going to see magnet bits. I mean, isn't that what they were talking about? One is in glass, one is in plastic, and these things have been sitting here for months. So I don't know if that would be enough time to see something under a microscope of, magnet bits, water. Isn't that aligned with what you're talking about, Mark?
There you go.
I'm sorry, I wasn't really
Like-
paying attention to that question.
Like weight gain in a Faraday cage. You expose it to something else and it gained 4 grams. Well, this water, it's exposed to sun rays. And according to the previous speakers, they said that it creates bits of magnets in it. Just regular, water. And wouldn't that be mass increase from the original?
I have no idea.
And this is just a simple, like,
I've never heard of an experiment
Application
exposing
to-
water to sun rays. I mean, that would lead to tidal flooding if that was true. The oceans would change in mass if that was really true.
yeah, but I have it. They have it like capped, corked, so it's sealed, completely sealed. Like really, really sealed. And 2 different types of containers. One is glass, one is plastic. Like, see, one, the suctioning kind of happened. One still holds its form, its form. So, I mean, it's just, you guys were talking about something that it just happened that it's there. Like, isn't that the same thing? Sun rays produce all sorts of rays. Well, two different kind of rays in an encapsulated container that's made out of H2O. Is that creating magnets, bits of magnets? Different rays that are, crossing to, this is just sitting in the backyard. It's been exposed to the sun.
Magnetism is spin orientation of valence electrons.
No, I was talking about creating matter, excess weight, just by different rays bombarding each other in a closed, seal to create matter. I mean, this is, I believe, this is what we've been talking about, like, since the beginning.
No, nobody's talking about making matter using sun rays.
Then I think you are misunderstanding the whole, what quantum physics is.
To look at your point most generously in light of our speakers, or the invited speakers, Bob Greenyer is most congruent with your argument because he's talking about ionization and certain phenomena that are not universally accepted. But he talked about a kind of a black hole phenomena where ionic matter is disappearing. And he talked about another phenomena where elements are being transmuted under bombardment by ions. If to try to simplify and state it, I could be a little bit off. But in light of your remark of sunlight can contain ionizing radiation in the UV portion. So it's not impossible, but I think that
I didn't
Mark,
say it. The previous speaker said it. I just want to clarify. I mean, you're telling me about Mr. Green, but you guys just had a speaker that was talking about the exact thing that, I'm just trying to tell you guys.
My mistake. I was just saying that the original speaker said something that kind of relates to what you said.
Sir, science doesn't have mistakes. It's experience. You learn. There's no mistakes. No mistakes. You just learn. I mean, that's the whole thing. How are we gonna know? And so, I just want to put the whole idea together. I mean, could we create matter, heavier elements from lighter ones? The first abundant element.
One of the things Bob Greenyer mentioned was about cold neutrinos, and cold neutrinos are stationary in space. So he mentioned that some reactors only work in the springtime or in a particular phase of the moon, because the moon might drag cold neutrinos around, or there might be in a particular position in the solar system. So based on where these LNR reactors are on the Earth, they will only work at specific times, because, as he said, there was a researcher that said he would only, when he took his reactor from one physical place in his lab to another physical place in his lab, it would start producing strange radiation. So it's not necessarily that it's being exposed to the moon or the sun, it's that the cold neutrinos are present or not present because they've already been used up, or they're still in that area.
Thank you.
Can I go back and talk for a second a little more about the nonlinear damping?
I think it's open.
Please. Yeah, so there was a guy who worked around Area 51 back in the 60s, and he wrote a bunch of books about his experiences in the 80s called Millennial Hospitality. His name was Charles Hall. One of the interesting things that he mentioned was he saw these, he called them tall whites were the creatures. He said that they had tic-tac shaped things. He's writing about this in the 80s, way before the Nimitz incident. He's talking about Tic Tacs. And at one point, he even got to see the insides of one of them. They were like working on it. And he said that they ended up having to bring in truckloads, like over 1,000 miles worth of fiber optic cable to be able to like rebuild their craft. The cool thing about that I've noticed is with fiber optics, whenever you're dealing with solitons, you're creating what's called surface acoustic waves. And these are basically the same thing that I was talking about earlier with the vibrations between the two phases of a metal. You can get similar type of vibrations happening on the surface of fiber optics. And it's much smaller, but if you have, thousands of miles of this stuff and you're operating at far higher frequencies than any of these mechanical magnetic spinning things we're working with, it can scale pretty well. That was basically all I was gonna talk about.
Jared, I didn't quite get your last two sentences. Could you rephrase them?
The gist of the whole thing was that a dude in the 80s talked about Tic Tacs, the flying Tic Tacs that he saw around Area 51 and the creatures that flew them. He said that they used 1,000+ miles of fiber optic to rebuild one of them. And that he got to look behind the panels one time and see like the fiber optics and the magnetic coils around them. From some of the research that I've done, it sounds like solitons being fired, which are just solitary waves being fired through fiber optics. You get something called birefringence, which is like this back reflection of the light, and it's exchanging its energy between photons, the light, and phonons, the acoustic vibrational momentum energy. So with nonlinear damping, like Woodward's Mega Drive, you can capture these phonons and you can capture their momentum, and you can have, propulsionless or not, propulsion in space without exhaust. It takes a whole lot of energy for being able to scale these together in a way that is actually able to like move your craft, but it's far less than like out-to-bear drives or anything. It's orders of magnitude less. That's all I got.
Going back to what Lulu was first asking, saying what do we all have in common? And I took a very broad view of that outside of kind of the APEC community or engineering writ large at all, but just life. And because I've had the opportunity to teach biology recently, and I try to think of a definition of living things to give my students. And many people say, well, it's kind of an ill-defined term, life, but if we were to try to name some characteristics all living things seem to share, there's an underlying order, there's kind of a resource economy, gathering resources, using them, expelling waste. And what I found was interesting is the point some more kind of mathematical sources gave was that they all living things exhibit a sensitivity to initial conditions. And some of us that have been in the math side will recognize this off the bat as the definition of mathematical chaos. So on one hand, you have this definition of order. There's kind of a cellular structure. There's kind of a predestined or predefined kind of order. Many people cite that you will have, the cellular architecture defines life. That's probably a pretty narrow definition, considering all the different domains of living creatures, but there is an order with all living things. And at the same time, you have that sensitivity to initial conditions. This is what was noticed in early attempts to model meteorological systems. And they found that if they took the same input data, but just rounded it to 2 different decimal figures than a previous run of the simulator, they got drastically different results. And it's called the butterfly effect. And that's even interesting in the poetry of this thought that, the notion of mathematical chaos is characterized, in fact, by the presence of a living being that affects a system that is unimaginably huger than it so profoundly.
I've got something to say that's changing topic a little bit. It's from a brief Facebook chat I had with Bob. I was asking him about vibration of plates and the sono cavitation type machines. And he said that the vibration and the formation of cavitation is right on the plate surface. And we got into discussing how it'll be like a cymatic pattern right on that surface. And so there'll be like, imagine sound waves crossing each other. There'll be nodes and antinodes. The antinode where there's the most amplitude of motion of that metal, creating the cavitation, I guess, right there near the plate. I hadn't thought of that it is occurring so close to the plate. And I'm sharing this because I think we can now start thinking of what metals are even better than steel, and getting them to the right shape and the right frequencies to all be tuned to have the maximum amount of antinode spots available, that sort of thing. I just throw that out there.
Casual inspection of some of these cymatic patterns reminds one of Penrose tilings and other kind of forbidden symmetries along the lines of quasi-crystals. To my understanding, that those minerals don't have particularly desirable kind of bulk qualities as far as like tensile or other strengths or anything, but they do exhibit profound symmetries that are very useful, right? Like icosahedrite, I think they've proposed some uses in the engineering domain for that. Also, one of our presenters was echoing my appreciation, or I should say, we kind of both chimed on the appreciation for theories that posit perhaps a quasi-crystal structure to space-time itself. If you look at some of these cymatic patterns, the way that the waves spread in such a perfect yet quasi-periodic way is quite fascinating, and it seems like something that could be exhibited on the deepest levels. I don't know if anybody has any thoughts on that.
Yeah, there's been a couple good researchers out there on octonians. Cole Fury is one of the good ones. Tevi and Dre, another one, right? And the octonians are like the Lego pieces for string theory. If you want to build a 24, a leech lab, a 24-dimensional structure, you're going to have to use these 8-dimensional things to build up to it. And these 8-dimensional octonians have all of these wonderful symmetries in them, but because they are mathematically like as simple as you can get, right? They're the what is it, non-divisible or non-associative and can't remember the other one. But yeah, without octonians, you can't build the universe.
They're not quite a field. What are they called? A division algebra, right?
That's the one.
They're analogous to a field, but one of the operations is non-commutative. The multiplication is non-commutative. And for some reason, to me, that always seemed like it was still an algebraic field. But because we had that convention that it be multiplicatively commutative, we don't have that option. You know, algebraic structure is a very beautiful thing, but sometimes you want to get rid of algebraic structure. You know, a lot of like Feynman integral type calculations are done just at the level of a semigroup, and you may not even have a inverse or anything to work with, much less and you know, while in your like coordinate space you may have the structure of a field or whatever. You know, of course you'll have a vector space or a module somewhere in there. You're at the level of like a Lie algebra, you're trying to kind of generalize very kind of crudely in a sense, and you want to slap down some of the symmetry to give you more freedoms. Is my feeling on it. I'm not a physicist.
I've heard some on the alien woo side of things. I've heard them talk about ternary computing, and I've seen some papers out there that suggest octonians work very well for ternary computing. They're also extremely useful for optical processing, but that's going down the holographic theory, and I don't touch that with a 29.5-foot pole.
You know, you only need quaternions for plenty of kind of advances in 3D, you know, simplifying working with 3D. I think octonians have their use definitely in physics. Cole Fury, really, that's amazing contribution that she was able to make at such an early stage. What I understand is these were kind of forgotten theories that got a good start in the 70s. But be that as it may, even if that's the case, and that's just what I thought I remember hearing, Cole Fury's ideas are very, very attractive. There's a guy many years before, he was way more underground. He had graduated from MIT with a degree in biology, if I remember right, and he had a similar idea to Cole Fury's, and I think she's actually largely building on it. Not to say she read his work, but that the mathematical structure is an extension. So he had the quaternion part. This guy, Doug Sweetser, he's kind of cool to listen to on YouTube, but he's a lot less definitive than, say, Cole Fury. Cole Fury's got a bunch of great publications out of what is it, Oxford or Cambridge? I think she's got at least 2 well-cited publications out, and it's got its detractors. I forget what they say the problem is ultimately with kind of an octonian field theory, but I think it's promising. Our speaker, were you here? I'm sorry, I'm gonna call you whimsically ambitious. I know you did give your name, but did you hear the second speaker? He gave a bird's eye view of everything you could do to general relativity, pretty much within the confines of just differential geometry. So we're not gonna bring in too much weirdness outside of what happened. I mean, because you get Lie groups and stuff when you do that. So, you know, then you get your algebra Lie symmetries. But beyond that, we're not gonna bring in too much outside of just straight up like geometry. Riemannian, pseudo-Riemannian geometry, right? And that was a freaking comprehensive like world tour of the subject, right? So I didn't even really appreciate that by always including torsion, like a lot of the folks that I read always did, or professors pointed me to stuff, that's actually Einstein-Cartan gravity, right? So I was always very interested in it. And just in crudest terms, can somebody, if anybody can kind of confirm this, but like a lot of us are talking about in here about like gravitomagnetism. And for me, what that is like our presenter was talking about heavy side gravity, just naively proposing Maxwell type equations for gravity. And when you look at those laws, there's a solenoidal field and there's the vorticial field, right? There's the one that has curl, the one that has divergence. And we think of gravity in the orthodox teachings as just, well, it just pulls. It doesn't really spin on stuff. Now you can get into your different connections and all that stuff when you want to get fancy with differential jump. Go ahead.
Have you seen some of the Rodin coils that are made where they have the magnetic sphere inside the hole of the torus of the coil, and then when they power it up, the magnet both levitates and rotates right in the middle, and they're calling it like the counter space area, because it sounds pretty much exactly like that's all I had to say. Have you seen those, the Rodin coils where they're spinning the magnets and they're
I think that's where respecting that gravity might have a curl, right, to loosely speak, would lead to the development of these machines, perhaps, if you have strong enough magnetic fields. There's a podcast called Physics Frontiers, and just recently they did a overview of some electromagnetic field propulsion ideas for space travel. I think folks in here might like it. It's pretty technical, probably not near the level of technical wizardry as David Chester, but it is technical general relativity and gravity theory stuff. Sorry if you were trying to talk, Bernard. I think your speaker went out in and out, at least on my end. But yeah, so I had posted in the chat that one of the things I heard in there was that the gravity probe B measurement, that if I remember right, came out in the O somethings, in the prior decade, that the gravitational electromagnetic field strength was about 10,000 times higher than predicted, has actually been scientifically, I wouldn't even say debunked. I think that what they implied was that the authors recanted this. They said that there was gases present in the device. However, everyone agrees that these fields exist. All right. So while the magnitude of the strength of the GEM field is still kind of open territory to pin down exactly what it is, the fact that there's another field of gravity that hasn't fully been appreciated. I think Howard was his name, was asking about the quantum implications of this. And there's likely to be some, even though it's a little subtle, because while there's not really a magneton, it's part of the field that gives rise to photons, right? But it still is part of the electromagnetic radiation. It's still part of the field that defines the photon. So, could this feed into detection of the graviton or anything? Are a lot of us like super skeptical about like quantum gravity? Are there any people that believe gravity will never be quantized? Where are we on that? Are we, some of us like hardline like GR people? Are some of us thinking there's like that general relativity is not right? Or we're skeptic about like special relativity, length and time contraction, moving clocks run slow, all of this. Like that'd be interesting to know as a community, like where our physics kind of views are.
Hey, John, could you spell Doug Switzer's name? Sweetser, sweet, thanks.
Well, I'll chime in. I watched one of those David Wilcock courses, and they had their insider named Beskar, Chris Beskar. He's the CEO of Stavati Aerospace. And he was saying that for their invisibility shielding of craft, they were, what would I say? They built a layer that would contain these spinning vortices of energy, which to me sounds like EVOs, and anything that would get in there would never be able to come out. And he implied that the same principle happens if you want to do anti-gravity, is that you just get these superconducting little spinning magnets all packed together in a hexagonal pattern, like donuts that are squeezed together, and you contain them in a bilayer of stuff, and the magnetic energy that is gravity is just going to get sucked in and never come out, and then you're away from the effect of gravity. So that's my little contribution to the chat there for now.
So that's almost bringing in kind of the gauge part of quantum gravity they were talking about, that you've basically found a situation where gravity eats itself. And not to say, you know, one way or the other from my end, but that's kind of what I'm hearing, and something like that might not be impossible. I just heard on a related idea, I heard something kind of negative to that exact result, but about why the mass, why is it that black holes can still gravitate, right? If all the mass has fallen into a singularity on the other side of an event horizon, you know, how does gravity escape from the black hole if not even light can escape? And furthermore, recent results have shown that gravitational radiation propagates at the speed of light. How is it that the black hole has any effective mass at all? And explanation is pretty convincing. I don't know if folks have thoughts on that, but it's a pretty interesting thought experiment. I had done some calculations in fractal geometry that led me to believe that a gravitationally collapsed system of a low enough fractal dimension might actually disappear in this way or not gravitate. But I never got beyond kind of making an analogy.
It sounds like the quasi-crystal universe that we live in, it devolves into like a chaotic crystal once you get down to the too small or too high energy density level.
And of course, last time we were talking about the big rip and the false vacuum decay Remy was bringing up. Yeah, it looks like Remy might not be in here now, but between the false vacuum decay and now there's a new Cuban Missile Crisis. So let's all try and cheer him up next time we see Remy.
I'd like to add in one more thought on this topic is if you think about EVOs, spinning rings of energy in water, we've heard discussions about how water molecules can be attracted and held in some sort of a structure, and the ring is preserved within that those water molecules, like in a 6 or a bigger thing with that. So that leads me to think you could probably achieve the same thing with different atoms in a bilayer or trilayer that are not liquid, but that could provide the lattice for a superconducting ring of energy to persist.
You were mentioning a toroidal structure in the EVOs. The other interesting thing about the concept of an EVO, I'm not, I can't say I've thoroughly vetted the observational evidence. Let me say it that way. But the interesting thing about just the idea of it is that you have this vacuum that is existing within condensed matter. Is this not the case, right? You're within water or air or laboratory substances.
Yeah, like, and it seems that it's always the magnetic. Ken Wheeler theory hypothesis on YouTube does really good demonstrations of that with his ferrocells. And then if you guys have heard of Ed Lead Scallon and his magnetic current, he also seems to show the same thing and works with his the flywheel. It's pretty interesting toroidal systems.
There's a pretty recent paper out from the Royal Astronomy Society in Britain on toroidal just orbits in celestial mechanics. I was talking last meeting about the kind of spirograph nature of the orbits of the planets when viewed from, say, a planet or the barycenter of the solar system or the barycenter between that planet and the sun. There's different coordinate systems that are used in a paper from the company, actually, PA Semi. It's, for some reason, it's on the archive, and the author is the legendary physicist Pa Semi, but that stands for Palo Alto Semiconductors. And because no one wanted their name on this paper, and you look at what do orbits really look like, right? Because sure, it's wise probably to tell kids that the center of the solar system really is the sun, but there really is no center. There's no preferred coordinate frame in the universe. You might as well center your spacecraft, basically yourself as the center coordinates. That's what's going to be most useful for navigating the universe. And when you do this, the orbits of the planets look much different. And they look like the output of a game called an a spirograph. And if you think, we were talking about quaternions and octonions, right? So if I think of that spirograph as drawing in the complex plane, and I wonder, what if these are traces of quaternionic quantities just being projected down onto the two-dimensional plane, then those rosettes that are formed, all the different kinds of epicycles, and there's these different families of these figures we talked about last time, such as the hypotrochoids even, they will trace out the exterior of a torus. And if the so-called ratios are not rational between the gears, in an analogy to an actual etch or spirograph toy, that will actually fill out the space. So in relation to the Royal Astronomy paper, Royal Astronomical Society, they envisioned a cloud of gas and dust. They actually computed that the orbit that will be the attractor for all of the gas and dust in a general accretion disk around a star will actually trace out the surface of a toroid. The interesting thing about applying the toroid here is that it's a topological product of two circles. So it's really just two cycles occurring with whatever their ratio or irrational ratio between them is. And this was shown. This has a lot of the regularities actually of a fractal set, like the Cantor set. If you look at if you trace out a what is that called, a phase diagram on it, that's actually the wrong word. Phase diagrams in thermodynamics. If you make a phase portrait of a system on its toroidal orbit, you'll get a strange attractor, and a section on that strange attractor will be a Cantor set. Then the mathematics of this Cantor set will you can demonstrate with a Dirichlet series. This Dirichlet series relates through a change of coordinates in along the imaginary axis at a given real value to a Fourier series that traces out the original orbit that we were talking about. Oh, it looks like I lost you. All right, Bernie. We'll check out Bernie tomorrow. So if it's my thinking that if, you know, the torus is the general orbital shape that a bunch of matter will descend into, the only thing I have against this paper, it's just so clear. So it can't be this easy. So I have to give it another read. But it's a very nice paper on if you Google search toroidal orbits, it's the one that's from the Royal Astronomical Society. I think it's within the last 5 years. And if that's right, I don't know that you need this collapsing gas cloud argument. I think that they're saying, I know we just said there's no preferred frame of reference, but the kind of path of least action is not going to be the perfect ellipse, because you're going to have, you know, you're going to have vertical wobble, you're going to have the eccentricity, and then over the course of orbits, that's going to trace out a strange path indeed, perhaps. We know this is the case, at least with the shepherd moons of Saturn, but that's a very special arrangement. You guys tripped out on the Saturn system? The freaking planet is a gas giant, and it has a giant hexagon on the North Pole. Have you seen this? Is this the largest regular polygon known to man? Right? You got, I mean, like, that's insane. Is it sign? I mean, is that a sign of exobiological
It's called one of the
processes?
Titans. It's called one of the Titans. I mean, that's what history teaches us. It's one of the Titans. So it's going to be humongous.
I half believe it. I've seen some interesting speculations from fluid dynamics that attempt to explain it naturalistically, but man, it's a striking structure. There was a long-lasting radio source in one of the rings of Saturn. Didn't that die down pretty long while back, but it lasted for like 20 years or something.
Michael Salla and his exopolitics, he's been talking about it a lot lately. Not the hexagon.
I guess we're not supposed to talk about exopolitics either, but I will throw one quasi-political thing out here, and I think this applies to all of us wherever we are in the political spectrum, is APEC. I would like if we had like a logo for a t-shirt. What if it could be uplift, right? And I mean that in all senses, whether it's levity, like a sense of humor, whether it's just good old anti-gravity physics, man. Like I'm ready to just like hold down that remote and start accelerating at 1G away from the earth if I wanted to, right? Or whether it's honestly like being invested in the shared goodwill of all of sentient life out there in the universe, and that especially includes the earth, right? And you know, that's as far as I'll go. I won't mention any actual political stances, but like, and I think like when I see people that I feel like are on the opposite extreme of the political spectrum, but they're in here, so I know that they're doing uplift too. You know what I mean?
Listen, the true leaders are the scientists. Everybody else is just it's a popularity contest, nothing more. You know, whatever you see, you don't know how many hands it had to set up, you know, for that imagery to be broadcasted to society. You know, you just have to be more mature than when you see something on the news and you see depth in it, or you see what the scheme of possibility could be, you know, of why this is happening. And it's always to combat something really fundamentally inhumane, you know, and however you want to look at it, the idea is we need to evolve and drop the whole stereotype, archaic belief, you know, just, I mean, take the borders out and think of people as people, like real people. And then you start to see we all share a lot, you know, and our mission is to eradicate anything that is oppressive, anything that is wrong, anything that, you know, is conditioned, you know, we want to free the mind. If we're going to free the mind, you know, sometimes you have to have puppets. You have to have people like, you know, that want to do the popularity contest and, you know, want to like, you know, condition people to iconic words or statements or things like that. But the real people, the real thinkers, the ones that, you know, don't care about this stuff, care about setting up this stuff, then everybody else follows. You understand? That's the real leadership is. You know, I look forward to you guys. What, you know, I get to see, you know, get to talk to intelligent beings every 2 weeks. You know, and I like that. I don't want to waste my time on talking to people that, you know, like hurt my head and not understanding. I would rather limit it to a few people than have the whole world, because few people on sync it propagates the whole world. You know, so yay, no gravity.
APEC, proving the existence of intelligent life.
Jared, what kind of results have you seen so far with your GraviFlyer?
Well, like I was saying, I haven't been able to get it fully wired up yet because I'm missing a 47 k ohm power resistor that apparently didn't get shipped from DigiKey. So now I ordered another one. So a couple days and I'll be able to actually do it. But in the meantime, I started off by taking a bunch of tables of results of the acoustic resonance frequencies for each of the plates. So the top spinning plate, the flex plate, and then the magnetic plate. I got some interesting results with those, but as soon as you put your bolts through the whole thing, it changes the resonance. So I went back and I checked just the resonance of the flex plate after the acoustic resonance. I suspect that there is I suspect that it is in, if you look at the different, I wish I could share my screen, different modes of circular resonance. The mode 3,1 is one where
you can share your screen. Just push the green button on the bottom.
It's on my phone and I'd have to link it to my computer. I apologize, I can't do it at the moment. But the gist is that with a circular resonance of 3,1, you get at 120 degrees, you get nodes, and then next to them you get your antinodes. And just the sheer fact that Alexei placed his 3 struts at 120 degrees apart, I think is interesting in that if it is creating some kind of nonlinear dampening, those struts are probably going to be at the intersections where the nodes and antinodes are flexing, because otherwise they'd be dampening it. So they probably help with that. But other than that, and testing around with some magnetic paper tests on the magnets, I haven't been able to get my high voltage up to a high enough voltage to test yet without my power resistor.
Copy. Was anyone else here working on actual experiments? Tony Robertson, are you there?
Yeah, I'm here.
Hey, you're hiding out in the background, aren't you?
Yeah, I'm just listening. I haven't done anything with mine. In fact, if somebody would come by locally and mess with it, I'd be appreciate it, but most of you guys live too far away.
Are you going to come down with Brent to New York?
Haven't heard anything about going with Brent anywhere to New York.
Oh, he's going to be here, I think, next week or so.
Okay, now he hadn't told me. I'm just doing some experiments so I can write an SBIR for them here soon. So I've been pretty busy on that.
No more grab flyer work?
Not until I can find time or get help.
Hey, Mark, you said that you guys were building a gravel flyer in your lab too, right?
It's already built. It's right over there.
Oh, nice. Hey, I was curious, what kind of current were you getting for the piezo and the high voltage?
I didn't actually build it. This was made by a guy named Chris Hardiman. You might have seen his YouTube videos. So for the piezoelectric, you should really talk to Charles Crawford or Todd Desiato. Right now, Todd has been investigating this gravity flyer device one step at a time. First, he did the spinning magnets. Now he's working on the ultrasonics. We got a high-speed camera capable of like 500,000 frames per second to be able to really dial in exactly what's happening at a very fast rate. And he has equipment that goes up to 50 kilohertz for the piezoelectric and for the sensing side of things. Ugh. And it rings with interesting harmonics.
One other thing that I was doing with it that I forgot to mention, I forget who it was, but to get the EMF meter, the tri-field meter, somebody mentioned do that. So that was like one of the first things that I did. And so I was measuring the fields all around the thing just as I would spin up the mag plate and the counter rotating plate. And yeah, the magnetic field alone is like orders of magnitude too small. You're at like half a micro Tesla. And if you want to lift something this much, you got to be in the multi-Tesla range. So it can't be just straight magnetics that's lifting this thing.
Yeah, but like I mentioned before, when you spin magnets around, they seem to they seem to adhere to forces of nature, like to the magnetic north of Earth, a lot stronger than if they are stationary.
Hmm. So then the graviflyer would operate differently at different latitudes, you think?
I'm not sure about that. But
or wherever the magnetic fields of the planet are strong, have different.
It's sort of like a compass effect that it's, you know, the compass pushes with, let's say, 0.5 gram at whatever that force is, but when you're spinning the magnet, it's suddenly at 10 grams. But I don't think at any of the latitudes that they flew, the gravity flyer was the magnetic field pointing straight up. No, this is something else is going on there. But a spinning magnetic field does not act the same as a stationary magnetic field. Oh, we have, what's his name again? John Hutchison is on the YouTube channel right now watching us, and he mentioned Boyd Bushman. Boyd Bushman effect is when you stick two magnets in opposition, they fall slower than the speed of gravity. This has been shown actually by several experimenters, and one of the first things that I was working on about 4 years ago, putting two really powerful magnets together. I still have them over here, but I chickened out when it came to doing the drop test because I had no way to cushion the fall. And I realized there were so many people have already tried it. And the goal is not to fall at 0.99 speed of gravity. The point is to fly. So like, where are you gonna take that? Hey, John, if you want to get on the Zoom call, I'll drop the link here in the chat. 1 second. Let's see if we can get John Hutchison on. That would be big.
I thought that part of the reason for why those opposing magnets pushing together were falling slower was because they're changing like either the energy density of the local field, you know, at the time that they're falling, or because maybe the mu or nu, right, the permittivity, permeability of the vacuum, somehow that gets altered under extremely strong magnetic fields.
Those values are so low that I don't see how you can be, you know, interacting with them directly. You probably have to change them first in order to interact with them. Mu and epsilon can be changed by, you know, the EVOs that we were talking about earlier. If you dump enough energy into space-time, you're changing the refractive index of space-time and its energy energy stored in space-time.
So I've been doing a lot of research lately also with the refractive indices and how that can help create some interesting effects. The birefringence that I was talking about earlier, where you get this back reflection through an optic when you put enough juice through it. There are crystals out there that have natural birefringence effect. Calcite is like a super common crystal that has some of the best birefringence that we got out there. And dipping my toe into woo land for a moment, there was a story from Ireland like 2,000 years ago about a guy who built himself a flying craft with the help of another dude that's mentioned in the Bible. And like there's stories all over about this flying craft that would like spew out light like crazy. So just trying to figure out what kind of elements that guy would have had available to him. Calcite is the only thing around that he would have been able to have any kind of major birefringent effect, but he would have been able to have it like in spades. He wouldn't have needed a whole lot of energy to be able to have a lot of phononic development coming out of this crystal from his pumping in of a bunch of light, like burning magnesium to make light, or whatever method he would have used to make a bunch of light to refract through this thing. It wouldn't have been that far of a stretch for him to, who knows, maybe be able to do it. His name was Mog Ruith, by the way.
Hey, Mark. Hey, Mark, it's Tim. You said John was trying to get on the call?
Yeah, John might be joining in. He was chiming in on the YouTube, and I sent him the link. He said he's going to try to log in with the APEC. We've been trying to have John on here for a long time. He's
you're the host, man. You're the host. So
I know. I'm waiting for that button.
Okay, good deal. Good deal.
Yeah, that'll be really cool. Oh, he needs to charge his iPad. Yeah. We're pretty low key here, especially the late hours after APEC's over. That's interesting what you talked about, Jared. A guy was able to make a flying craft. Apparently, back in the 50s or something like that, there was a disc saucer that was built by a guy in his garage down, I think in California, and was used a couple it was a terrestrial made UFO, probably somebody who was working on the ARV and had a couple vacuum tubes in there, and I don't know how it was flying, but it was out of control and it crashed. And that ended up, you know, over at Area 51 or Sandia, Los Alamos Labs.
I vaguely recall that story. I thought it wasn't like a full-grown man. I thought it was like a young kid or like a teenager or something that did it. And it wasn't super big. It was only like 3 feet wide.
Yeah.
And he flew it around town. Like people saw this, people talked about this. But yeah, it didn't last for more than like a couple of flights or a couple of months or something like that before it got yanked.
Isn't John Hutchison the one that made things fly through frequency, like of motors or one motor through oscillation, like, you know, the waves?
John Hutchison has been working with lots of RF equipment at high voltage, and he's transmuted metal. Things flew around.
I saw, and he made things fly. He made things like just, he beamed like.
Yes. In the early days, they got things to fly. There was a bowling ball that took off. There was a spoon that flew. Metal and wood were combining together.
Okay, those things that flew, like, what was he able to capture if the frequency of the material changed while it flew? Because, you know, they're blasting so much frequency on this thing that it flew.
You're like, asking very good questions, and we don't know the answers.
Fuck. Okay, let's wait for the iPad to charge.
Didn't John have to like leave his lab and all of his stuff, and like I thought he hasn't been doing much in the way of experimenting for like years.
I heard he's got a new lab set up apparently, and he's had them in Canada. Tim Ventura knows John a lot better than I do. I just know him through Facebook messages and whatnot. But Tim's actually been down to one of his labs. There's been instances where stuff has been confiscated, and people tried to replicate his work, doing exactly the same thing, and it didn't work. So then there's a group of thought that it's probably you know, mind control over matter, telekinesis. Who knows?
Because physically he's there, biologically he's there. So remember, his DNA is being also bombarded by the same thing. I mean, if he's physically present, whatever is happening to, you know, the object, somehow he, you know, it's going through his, you know, his own.
Well, he doesn't have cataracts, so he took care of protecting himself. And I saw him a couple pictures with the tinfoil hat, so he was protected.
I'm not talking about titles or labels. I'm just talking about like quantum stuff. You know, when you want to collapse a wave function, you put a camera on it, right? So then it takes a left or a right. Let's just say that. Same thing, but they don't account for the actual measurement of the device that is collapsing the function. Usually, you know, according to the equations, it accounts for a half, because, you know, for uncertainty, the principle of uncertainty. So
John actually mentioned that it's the telomeres that you're destroying. Telomeres are when you replicate DNA, they're the junk DNA at the end that sometimes gets bitten off during the replication process. So that's a great way of measuring your age. But maybe
John measured all of his stuff though with like cameras when he wasn't there, and it would levitate and it would jump and it would do stuff when he wasn't around. So I have a hard time wondering about the control thing, if he's not doing it with, you know, direct perception, if he's gone, you know, off somewhere and it's still doing these crazy things, then we're getting into like collective unconscious realm, and he's doing it in his sleep or something, and like it throws a lot more variables in there.
No, it doesn't. It's whatever his like metal core. Like we all have a core, and if it, you know, sometimes it's that last that's what makes the difference. You know, and you have to kind of know that to know how it's going to interact with non-living matter. really matters. You know, say what you want to say, but I know I'm 100%. I mean, maybe even more than 100%. Sure.
Yeah.
Listen, our metrics of conversions of, you know, the Planck's constant, that varies. Come on.
Someone mentioned Laurent Notal, the French theoretical physicist, earlier, and his thesis precisely is that the fundamental constants of nature are they are dependent on the scale at which you measure them. Sorry, they are independent of the scale, which is virtually, though, kind of like Lulu's point, because if I, you know, zoom into the Planck scale, I expect the Planck scale to be larger, but it's Notal's contention that it will actually still be a tiny quantity, even if I were to zoom in at that scale, so to speak.
The invariant scale is just like invariant light speed. Like, no matter how fast you zoom into the scale, it's always going to like retract from you by getting smaller and smaller.
It all depends how you calibrate length.
It's got to.
Oh, John also mentioned in chat over here, there's something called TA65, which has helped him counteract the cataract problem. That and some vitamins. So if anyone's playing around with high energy shit, get some of that TA65. I'm gonna look into that right now. That's for regrowing your telomeres.
Oh, no way. Can we live forever then?
It's an anti-aging cell rejuvenation, $100 on Amazon Prime. Oh shit, this stuff's expensive. It's like $3 a pill.
One of my kids suggested something. It was kind of funny, but true. He said, what if we travel close to the speed of light, far enough, and that time reference, and then come back? She said, wouldn't the people on Earth be older, much older? I said, yeah, but she said, we would have spent only little amount of time when we came back. She said, well, what if we did it over and over? Wouldn't it to the people seem like we're living forever? I said, yeah. Right. Think about it. You know, depictions throughout history show the same illustration of, come on.
I think von Daniken did hit on that and say that, you know, immortal figures in legend and myth were likely relativistic speed star travelers who would return, and perhaps they had long lives, or perhaps they had cryo sleep, but still the fact that they traveled such great distances aided them to appear to have millennia long lifespans.
Just to touch back on something that I said earlier about that Irish guy that built his craft like 2,000 years ago. Supposedly he lived for like hundreds and hundreds of years. I think through 25 or 26 like reigns of kings. And that's like a common trope in a lot of the you know, UFO contactee type of thing. They always talk about temporal manipulation whenever you start dealing with any of these unknown crafts. So, I mean, who knows? Maybe we can live forever just by making the right kind of flying saucer that lets us, you know, move through time slower or faster.
But it'll just feel to you that it was just a few years, but it might look like a long time to someone else. So you still need to take those pills that to get your telomeres up.
Yeah, no, I
They're
take,
expensive.
they are
They're-
expensive.
Yes, they're very
Yeah.
expensive.
No,
We're
I know.
talking like $3,
I take-
$4 a pill.
I realize that I take them every day and I have been for several years now.
Okay, give us a review.
Yeah, no, I take a product from LiveCell or LCRhealth.com called Telegenesis, which is it's telomerase. So it's it metabolizes into a telomere lengthener. That's what the ACE means, is that it's a biological precursor to, or a digestive precursor to the biological lengthener to telomeres. So telomeres are the end caps to DNA. They actually hold it together. There are some yeasts and bacterias that will cause your body to lengthen the telomeres, and they're common in like things, even things like bread, but they're very, very, very low quantities. Like the percentage of telomerase occurrence in bread is very, very low. So they've been able to culture these things or culture bacteria and yeast in order to extract it and turn it into a pill. And you can find them on Amazon. Yeah. I specifically buy them from LCR Health because they're
Josh, can you post the link to that in the chat? John
Absolutely.
Hutchison is joining us right now. This is a monumentous. We've been trying to get John on for quite a while.
I'm going to shut up. Hi, John.
And he's connecting to audio.
Is this something like you could just buy from the shelf, or do you need like a prescription, or what do you need? Like,
It's off the
something
shelf.
like that.
Yeah.
It's off the shelf. You can click the link I posted in the chat.
Hey, John, can you hear us yet? You're still connecting to audio. Ah, lighting up a joint.
Is this on record?
At least for YouTube, it is. This is the after hours show. How's it going, John? You got to shut up. You got to turn on your microphone. John, you got to click unmute.